In this lesson, we'll take a look at the width from light contour shader. So with this particular contour shader, this will allow us to actually control the width of our contour lines based on the orientation of a specified light. So a couple of things we need to make sure that we do before we actually utilize this particular contour shader is let's first take a look inside the Features tab. Let's take a look under Contours. We need to make sure that we have contour rendering enabled. And we also need to make sure that we have the contrast function levels and the store function both plugged in to the custom shaders. Otherwise, what we're about to do won't work. So now, once we have those features enabled, let's take a look inside the Hypershade. We'll go over to our Materials tab, and let's start by just dropping in this width from light. Alright, so we'll drop this in, and we'll take our different shaders. Take a look inside the shading group for these, underneath the Metal Ray tab, and we'll make sure that we have this contour shader plugged into the contour port of all of these different materials, so that way they'll all be able to utilize this. There we go, we'll drop this in, make sure that we get all these materials. Alright, so once we have that plugged in, what we can do is just simply take a look at some of the attributes that are on this particular shader. And you'll notice really the controls are actually fairly simple. We have controls for the actual line color, the absolute smallest or thinnest parts of the line, and the thickest parts of the line. And we can also specify some kind of a light that we want to derive this actual directionality from. So let's start by first just taking a quick render at what we have. And you'll see that once we render, we just get this mass of black. So let's go ahead and go back to the Hypershade, and let's take a look at the actual cause of this. The culprit for this is going to be found in the Utilities tab, and our culprit is the actual contrast node. Right now, by default, it's set to the actual difference of index. In other words, we'll get a contour line around every single triangulated polygon on our mesh. So let's make sure we disable that, and let's just make sure we have difference label and difference material, so that way we'll get some kind of a contour line around every different material in our scene. So let's render this, and now you can see that we get some of these contour lines that are behaving a little bit better, although you'll notice that at the moment these contour lines are very, very erratic. We have these very abrupt changes as far as the thickness of these lines go. So let's go back to the actual contour shader, and what we first need to do is actually define some sort of a light. Now in my scene, I already have a light set up, a simple spotlight. Now, if we were to simply middle-click on this actual shape node and middle-click and drop it onto the light, this actually won't work properly. So what we need to do is actually just inside the Hypershade. Let's see if I can get over here. There we go. Now let's take this, move it over to the side, and up inside the Window pull-down menu, let's open up the Outliner. Now what I'll do is take this spotlight, middle click, drag it into the Hypershade so that way we can have access to it down here. And now that I have the actual spotlight node itself, not the shape node, the actual spotlight itself, is we can take this, middle click, drag it onto the contour shader, and let's go down to Other. Now this will pull open the connection editor for us. Now what we need to do is take the spotlight's message and then plug that into the contour width from light. Now you may not see the actual message over here, so if you don't see it, what you'll need to do is go over to the left display, which controls everything displayed in this left-hand column, and activate Show Hidden. Otherwise you'll see that the message does not appear. So enable Show Hidden, and now we can connect the message. Once that's done, now this should behave properly. So let's re-render. And there we go. Now we can see that the actual contour lines are orienting themselves based on the direction of the light itself. So these areas that are oriented most directly toward the light receive these much thicker lines. These areas back behind here that are oriented very far away from the light receive these very thin lines. So right now, again, you can see that the result that we get is a little bit out of control. So let's go back to the contour shader, and let's start by dropping down the width to something a little bit more manageable. And we'll also start to give this some kind of a smaller width as well. Now, if we were to actually go back to our saved render, you will notice that we actually have a few of these little blotchy areas that appear. Now again, this is probably caused by the actual contour contrast node. So let's go back to the utilities. And right now, by default, this is set to create some kind of a contour line around any surface whose angle or orientation or normals are facing more than 90 degrees away from the camera. So let's decrease the sensitivity to that, something like 180 degrees, so that way we don't get quite as many of these little blotchy areas that just happen to be oriented right around 90 degrees away from the camera. So now with that adjustment made, let's re-render. And now you can see that we get a result that is quite a bit more controlled. And again, what's nice about this is the fact that it is controlled by the light itself. So if I were to simply take this light, and let's go in, look through selected, and reorient this light to another direction, so that way, this way it should be coming a little bit more from behind the character instead of in front. So we can save this for comparison. You can see now, once the render completes, that these lines have actually kind of changed their thickness now based on the actual orientation of the light itself. This becomes especially apparent on things like the eyebrows and around the eyes themselves, how we now have a much different level of thickness compared to what we had before. So that's a look at how we can actually control the thickness of our contour lines based on the orientation of some kind of a specified light source.